So today we are going to test a set of band pass filters, and I'm going to demonstrate how it can be tested with the two-port VNA system. Normally, most popular systems are nano VNA nowadays, but I happen to have this DG8 SAQ VNA Vector Network Analyser. Basically, these VNAs will have two ports. One is out port, which is normally used to do single port analysis like antenna analysis, and the two ports are used for in-system testing, like when we have to do filter testing, when we have to do some insertion loss and other parameter testing. Okay, so basically what we have to do is, first we have to calibrate this with the through and open connections. I have done that calibration already with my calibrated load system, and now what we do is, using these filters, we connect both of the ports. There is no it is a symmetric port system. Normally there is no in and out, but still, let us say for our demonstration purpose, we will consider this as input. So I will connect one of the out of this TX out of this VNA, or port 1 of VNA, to one side of the filter, and port 2 to the other side. Ensure that the connectors are tightly fit and they don't have any other problems. Okay. So basically you will have to just ensure that connections are tight and nicely snug fit with the proper threading, and then we go to the software of the VNA. Since I have already calibrated, now I have calibrated from 1 megahertz to 30 megahertz, which covers all the way from 160 meter band to 10 meter band. So there are multiple options out here. S11 stands for reflection coefficient. S11 VSWR. S11 has got a dB, which gives a reflection coefficient in dBs. VSWR is most popular. You all know what VSWR stands for. But S21 is the measurement of insertion loss. S21 dB is the insertion loss. We are interested in both S11 dB as well as S21 dB. Insertion loss should be very minimal. Normally the manufacturer will state how much is the insertion loss typically expected out of this filter. For example, here it is 0.4 dB plus or minus 0.1 dB insertion loss, and pass band return loss, which is a reflection coefficient, should be greater than 22 dB. So we'll measure that, how actually this performs. This is a 40 meter band pass filter, Array Solutions manufactured. Okay. So I will just now do a single sweep of the system in this. So we can see that the typical curves are there here. I will reduce some of the curves, and then I will just auto scale for the reference purposes, and we will do this auto scaling so that you all get the idea of where there is proper parameters are to be measured. So I'm interested in, I will remove all the, basically I have made some markers out here for 1.8, 3.66 megahertz, 7.04 megahertz. These are the markers on the graph, and here we are seeing that for 7.04 we are seeing minus 8.97 dB, which is not SWR would be high on this. We'll have to see why. And minus 0.44 dB, which is okay for the S21, which is nothing but insertion loss. Insertion loss should be ideally should be less than zero point 0.5 dB, minus 0.5 dB. More the insertion loss, the heat dissipation in the system would be, in the filter system would be more. And so if we can see this now what we can do is we can just so after recalibrating our VNA and reconnecting the instrument, we are seeing that our parameters are within the required ranges. Here for 7.2, it is 1.11 as a SWR, and insertion loss is 0.28 dB, whereas return loss is minus 26.07 dB. And also we can see the other markers at 1, which is around 80 meter band. We are seeing that minus 43 dB is a attenuation there, which is nothing but insertion loss, which is a very good attenuation. Similarly, on 14 megahertz or 20 meter band, it is minus 88, which is a very high attenuation on 20 meter band. Similarly, on 15 meter band, it is minus 52 dB. So basically, our operating range is between 6.8 here to say around 7.4 to 7.8 7.5 megahertz in this pass band. So one caution is we should not be operating anywhere else on the band, on the different bands. This particular filter, when it is marked for 40 meter, only 40 meter band should be operated. Because of the high insertion loss, it is a probability that even a fraction of seconds if you operate, the capacitors will go malfunction. That care has to be taken. Thank you.